Okay, so this is going to be the solution to a problem that we have, but let's explain that problem. Let's explain that problem a little bit first. Those of you who have built a stroker before know that that means you probably need to do some clearancing in the engine block. Hopefully we're really not going to have to do a whole lot of clearancing in here, but we still need to go through and check and mock everything up. Typically what you would do, we're going to put a rod bearing in and actually put the connecting rod and the piston in the cylinder, spin everything around and make sure that all throughout the travel we have 60 thousandths clearance.
Yeah, that would be a good number.
At all points, we want to check that the counterweights are plenty of clearance between the block and the counterweights. We want to check that as the rod goes around, it's not going to hit the bottom of the cylinders, maybe the pan rail up here. One spot that I heard on these blocks potentially is right here where the oil pump pickup tube screws into the block. You might have a little bit of a clearance issue there as the rod journal comes around. But one thing that I actually saw something on Facebook, maybe everybody else has already found this trick, but rather than using the actual piston to mock this up, we're actually going to take some time today and go out there on the lathe, and we're going to turn up a little tool that we can use to basically hold the connecting rod in place in the cylinder. And what that's going to do is we don't have to dick around with an expensive piston and potentially drop it as we're taking it in and out, because we're probably only going to want to do one or two at a time, and we're not going to scuff up our pistons. It's going to be less contact area on the cylinders for if there did happen to get the slightest amount of grit.
Well, that's it. As you're doing this, if you start doing any grinding, you're going to have grit all over the place here, and you certainly don't want that going up and down the cylinder wall with that brand new piston.
Brand new custom piston.
Custom piston.
So, I don't know. Maybe people have already seen this, but if not, maybe a trick they want to use at home, because I know there's a lot of guys who do this kind of stuff DIY, and I don't know. We've sold pistons in the past and had pistons come back broken and had to sell another set of pistons to people. So just kind of, mistakes happen, and we're limiting areas of that. So maybe let's head out to the lathe and we'll show you what we're going to do there.
Sounds good.
I didn't think this up. I saw this on a Facebook group that I'm a part of, so I'm not taking credit for the idea. But what we're going to do is we're actually going to turn two little end caps, I guess, or buttons, whatever you want to call them, out of Delrin. Delrin is kind of a hard plastic material. It's not going to screw up the cylinder wall as it travels up and down. And we're going to have one for this end of the piston pin and one for the other end of the pin with a spring in between there, a compression spring. And what that's going to do is hopefully as the connecting rod moves up and down in the cylinder while we're doing our mock-up, it's going to hold the end of that rod exactly where it would be if we had a piston in there. So just kind of a cool little idea that might make things easier for you if you were doing this at home. I know a lot of people who follow us have a lathe, or you could even 3D print them if you wanted to. This is our brand new TL-2 lathe. Pretty cool machine for us. We've never had any CNC equipment in our shop. We've actually never even had a lathe in our shop for over 40 years that my dad was in business. He always just willed the crankshaft grinder to make whatever he needed to make if it was around, which is not easy to do. But I have a little bit of lathe experience from 5 or 6 years ago when I was in college. I've been learning this process, and I kind of want to show you guys the entire technical process of how we can make this part. Like I said, I have very little lathe experience. I don't know a lot about running a CNC machine. This is all kind of stuff that I've almost been self-taught as I've been messing around here in the last couple couple of weeks, taking a little bit of time off with the new baby girl, but I actually had her out here in the carrier while I was messing around with the lathe the other day. So let's just go here. What's cool about this machine is it does have the hand wheels, kind of a remote jog for both the X and the Z axis. So we can actually move this and move the tooling with our 4-station turret kind of manually without having to be over there on the controller. So you can actually run this lathe completely manually if you want to. It's a little bit different than a true manual lathe because this is all servo driven. So you don't have as much feedback as you would if the handles were actually physically attached to the ball screws or the lead screws. The other thing that's cool about this is like we can switch the knob here and I can make it so that each tick here on the dial moves that 1/10,000th of an inch or 1,000th of an inch or 10,000ths of an inch. So you can kind of, you know, feed in really, really slowly, which is cool. But none of that really matters because we're actually going to use the visual programming system here to draw out our part just like this, and then we're going to run it CNC because that's way cooler than running it manually. I actually have all my tools already set up, so this is kind of an OD turning tool. This is a grooving tool that we can also cut the part off with at the end when we have it fully machined. I've gone through and I've already set up the tools and told the machine where the tips of those tools are, but we need to set where the end of our material is so that the machine knows how close it is to the chuck when we're doing our machining. So I'm going to go in here and hit offset. We'll go to work offset. And a lot of you who are watching may know all about this. A lot of you who are watching may know nothing about this. So it's going to be, you know, kind of interesting for probably all of you because the ones who know will be able to write comments about how dumb and how much I don't know about it. And the ones who don't know will think I'm an expert. Our part is actually going to be about 1.5 inches long. So I'm going to make it stick out. Let's go 1.7 inches. Because if I have too much of this plastic hanging out from the chuck and we're doing our machining out here, it'll actually start to flex the plastic. So it doesn't need to be perfect. I'm just getting close. But now we need to go into the machine and basically tell the machine where is the tip of this part relative to the tip of one of our tools. So I'm going to actually traverse this tool over just manually. Bring it in close, and then I'll switch to moving in 1,000th increments. And I'm just using this piece of paper as a feeler gauge. Okay, so it just got tight there. So now I know that the tip of that tool is probably between 2 to 3 thousandths from the face of this part. And we're going to use G54 work offset. That's a G-code CNC thing that to some people is going to make sense, some people it's not going to make sense. But it's basically where you tell the machine, this is where the edge of that part is. So I'm going to hit Z face measure. And now the machine knows that for that tool, when it is at this position, it's going to be touching the tip of that part. And I'm actually going to subtract, I don't know, maybe 3 thousandths from that so that it's actually up tight on that face. Now just for fun, I think we should face off this part here so that it's nice and true now that we have our work offset set. So I'm actually going to leave it right where it is. I'm going to go to edit and we'll go to the visual programming system up here at the top. Oops. So all of this is what they call conversational programming. So we're going to go to an OD turn and we're going to do a face turn. So it shows a nice little picture of what we're doing here. Tool number 2 in the turret, tool offset number 2, work offset number 54. Max spindle RPM on this machine is 3,000 RPM. Now, just from running this, again, I don't know all my feeds and speeds yet. It's just kind of been a trial by error thing for me. So I'm going to leave all that kind of there. We're going to bring the tool in 200 thousandths of an inch from the edge of the part, just so that we don't crash when it rapids in. Let's go number 9 to turn flood coolant off, because I don't need coolant on this plastic. The OD of this current, of the material we're starting with is about 1.01 inches. Finished diameter, that's going to be the size of where the tool goes past when it's turning. So we do negative 0.05 so that it actually goes past center. Otherwise, it would leave kind of a little nub sticking out. We're just going to take, well, actually, we're not even going to take 20 thousandths on this with where I have my offset set. And we can kind of leave all of that as it is. And we're going to run it. So I don't know if you want to come, I don't know if you'll be able to see if you come in close there or. So it didn't even actually touch. So I'm going to go to our offset. I'm going to actually subtract 20 thousandths maybe from our work offset. So I'm telling the machine that basically the tool needs to be 20 thousandths that direction to touch the face of the part. And we'll go back to our program and we'll run it. And that time it just took off 20 thousandths off the face. So now we have a nice, clean, flat starting surface on our part. Not that we really needed that because it's going to clean it up anyway, but just to give it a good spot to start with. So now we need to actually program the shape of this part. And I kind of had messed around and figured out what we're going to do here, but we're going to go through and show you the process. If it's not super interesting to you, feel free to skip forward in the video. We'll probably have some chapters put in, but if not, you can sit around and watch and maybe it'll be interesting to you. Back on the visual programming system, which is just their conversational programming is what they call it. It's where you can program the machine at the control without actually really needing to know or understand G-code. So I'm going to do a new shape. So the machine actually allows us to draw this part on here, and then it'll actually write the program so that we can make the part. So now we're going to add a counterclockwise motion. Our X diameter, I just decided to make that radius on the tip of the part 950 thousandths, or that diameter, I guess. It's just kind of an arbitrary number I chose. So we'll go 0.95 is the finish diameter where the X, on the X-axis where the tool needs to end. On the Z, it needs to be minus 0.475 because we're going to go half of that diameter since we're not making a full circle. On the radius, we're going to do 0.475. And at the end of the line, we'll put a 80 thousandths radius. So this green mark is our actual stock, and the black mark is the profile of what we're actually getting ready to cut. So now, do a linear feed motion. This is where it gets a little bit complicated. I want to taper down. The inside of our piston pin is about 625 thousandths. So I want to make this part 615 thousandths in diameter, just so it has about 10 thousandths clearance to slide in and out of the pin. So our X position, 615. Our Z position, I would make it just straight down like this, but the cutting tool that we have can't go at that aggressive of an angle because if it tried to come in, it's going to actually cut off the corner of that edge. So because of the geometry of the cutting insert, that's all the closer we can go. We can't make this 90 here because, like I said, it would cut off the edge of our radius there, and we don't want to do that. But we'll start with this. Again, I'm going to put 80 thousandths chamfer on the end of that, or radius rather. So now we'll just do a linear feed motion X position we're going to keep at 615. Z position, though, we want to go to minus 1.5, because I want from the very tip of this part clear over to here to be minus 1.5 inches. Okay, so you can see it's starting to look a little bit more like the part that we're making. From here, linear motion, and we'll go back out to, say, 1.1 on the X diameter and leave the Z at minus 1.5. And that's going to be our general shape that we're starting with. I'm going to save this shape. Let's name it vid part. You want your file names to be obscure enough that when you come back in 6 or 7 weeks, you have no idea what the hell they are. That's the trick here. So now we've got it saved as vid part. So now I'll go back to the visual programming system and we'll do an OD rough and finish cycle, OD profile removal cycle. Our shape, we want to load vid part. Tool number, we're going to use tool number 2 here in the turret. That's what we've got set up. Tool offset number 2, that's telling the machine where that tool is relative to everything else. Work offset, that's telling the machine where our material is. Max RPM 3000. We're going to leave the surface speed at 500. We don't need coolant on this, so I'm going to change that value to turn the flood coolant off. Our stock diameter, 1.01, it imported that from the shape that we made. So now there are different removal cycles that we can do. I assume that there are different efficiencies here. I'm going to just do a rough and finish combined cycle just because that looks like the cool way to do it. So what it's going to do is for its roughing, it's going to come in and turn down the diameter in these linear motions, and then on the final pass, it'll actually follow the profile of our part. Depth of cut per pass, we'll do 50 thousandths. That sounds like a happy number. For our finished stock, we'll leave that at 10 thousandths, 3 thousandths Z. Feed rate rough, we'll leave it 8 thousandths. Feed rate finish, we'll go 5. It's not that different. Rapid point pulled in from the file. I don't want to bring the tool turret all the way to the home position because that's at the far edge of the machine. So that would be like 42 inches or something like that in the Z-axis. So return X home, I'm going to leave it X, but we're going to leave it here at the max. So it's going to bring the tool turret closest to us, and we'll show that. I'll reiterate that when we're over here. On the Z, let's go 6 inches, 6.0. And what that's going to do is get the tool turret far enough away from the workpiece and the chuck so that when it does a tool change, it doesn't crash anything. And we'll just leave this optional stop in there. Okay, so now I'm going to hit generate G code, and I'm going to create a new program. Okay, file name, what do we call this? Vid part, file comment, OD rough. The problem is that's going to make this part. That doesn't look like this does. So now we need to come in with our grooving tool and actually take off that angled part. So I'm going to go back to Visual Programming System, OD Groove. That is in tool number 4. I'm going to leave surface speed and everything where it's at, because why not? At this point, our diameter is 0.95 inches because it will have turned this down to this diameter instead of our 1.01 that the material starts as. Our finished diameter, we want to be 615 again. From the start of the part over to here, I'm actually going to go back to the shape creator and look. Where was this ending? At minus 0.670. So let's just go minus 0.7. Let's go 720. Now our groove width needs to be from 720 to, let's see, from 720 to approximately 475, which comes out to be about 245 thousandths thick. We'll try this. If we have to change it, we'll change it. I'm going to put a radius on the top of that just so that it doesn't look completely ugly. We'll just go as big as it'll go, 087. Feed rate 3 thousandths, peck distance 50. So again, now I'm going to generate our code. So I'll hit F4, and this time I'm just going to insert it to our clipboard. And here in the editor, I'm going to load vidpart nc, od roch, and I'm going to go down here to the end, paste from clipboard. So now at the end of our roughing cycle, now we're going to have this grooving cycle here. I'm actually going to remove this MO1 also so that it doesn't stop the machine between the cycles. So now that'll take care of making this part square down here. Now we need to add in the part of the program to face this part off so that we have our finished part. So now we'll go back to Visual Programming System. Well, we'll just do part off. We'll leave that at tool number 4. Work offset, spindle, RPM, blah, blah, blah. OD diameter is 1.01, finished diameter minus 0.02. So Z cut length, we want to actually do, we want our part to come out at 1.5. Generate code, insert to clipboard. Now we're back here on the editor. I'm gonna delete that MO1, paste from clipboard. So now we have our part off here. And actually, after our grooving cycle, we don't need this tool change. Delete, 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 delete. Now we have our program written that hopefully will make this entire part. Now before I go and run it, I'm actually kind of a wuss and I don't want to crash into anything. So I'm going to go back to our offset and I'm going to add 10 inches to the Z-axis here. Okay, so we moved over 10 inches, like I said, and we just want to run this program just to double check that it does look like everything's in the right place and it doesn't do anything funny like switch a tool when it's way up close to the chuck or anything like that. So I'd say that looks about like it's 10 inches away. So there it'd be kind of roughing out the radius on the front of the part. Now it's going to rough out the stem, if you will. It'll move over 6 inches or so, do a tool change, come back in with the grooving tool, and start squaring off where the stem meets into the radius of the part. And one thing we should note is like, I have a ton of learning to do, so this might be a super inefficient way to make this part. It'll be interesting to see what the comments say. So did it do the part off?
Yeah.
Okay. I think we're safe to move our offset over to and actually cut our first part. So I'm going to go to this offset. I'm going to subtract 10 inches. So here it's our input from our G54 Z-axis offset. Going to hit yes. So now it should be back to telling the tool exactly where that part starts. I'm going to keep my hand on the big red button. Roughing out that radius. And you might be able to tell by the shape of that insert, you can probably see why we have to do it at a radius now, why it can't go in and cut a perfect 90 from that direction. There's kind of a rough pass. Finish pass. Tool change. Hopefully we went far enough over with that part of the program. It gets a little chattery on that when it traverses over on that finish pass. Oh, we gotta move our part off over. All right, 2 minutes and 30 seconds. And we almost have the part that I was trying to make. Guess we can just trim that off maybe. Take my knife out. Shout out to my father-in-law for coming up from Texas to meet his granddaughter and sharpening my knife while he was here. But I think that'll work for a finished part. It's not as perfect as I wanted it to be because I had to do a little bit of trimming there by hand, but you can see it fits nicely in there. And again, we're gonna have 2 of these. So we'll have that, and let's find a compression spring. And you can see it'll have enough pressure to push out against the cylinder walls and hopefully hold that pin and that connecting rod exactly like it would be if we were using a piston. So now we got to turn 3 more. Well, technically only 2 more, but we're going to turn a few more. And including deburring, in about 3 minutes, we have our completed part. And it looks pretty good. It's not perfect. Could probably be perfected a little bit if I knew what I was doing. But for a guy who has no idea what he's doing, I think it came out pretty good. So now we can go back into the other shop and actually do our clearancing on the block. So another nice thing about doing it this way is normally when you're doing all this clearancing, again, you have a piston in here, so you can't look down the cylinder and look at some of those critical points, because usually where you're going to hit is kind of right at the bottom of the cylinder as the rods come around. Just from looking down through, it's not as easy on the phone footage because I can't get quite the right angle, but from where I'm looking here, it looks like we have all kinds of clearance on that side of the bottom of the cylinder. And if I move it over to this side, again, all kinds of clearance on that side. I'm just going to go back a little bit. Again, we want to check a couple angles because sometimes your eyes will kind of lie to you. You can see all kinds of clearance with the counterweights. And here's the rod comes up. Again, from this angle, looks like plenty of clearance. Let's maybe rotate to this cylinder straight up and down. Again, looks like all kinds of clearance on both sides here. So I'm pretty happy. I don't think we're going to have to do any notching on the bottom of the cylinders at all, assuming that they all look like this, but just based off these first two on the right and left bank. We're just showing you all the angles so that you have as much confidence as we do. You can see plenty of clearance on that side with all of them. I'll check this side. Plenty of clearance again. There's probably close to a 1/4 inch of clearance, honestly. Switch to this other side. Okay, so looking at the further back rod right in here, it kind of gets maybe a little close, but honestly, plenty of clearance again. This right here is the only spot that concerns me. Right there where the oil pump pickup tube picks up as that rod comes around. And right now we probably have, I'm going to say 40 thousandths clearance. Honestly, probably would be enough. But I'm going to mark that spot so that we know, and we'll just grind, kind of taper that off to be flat. Probably if we just go right across like that, I don't want to weaken that point any, but if we just grind that black flat, doesn't even need to be that far back, I think that'll take care of the first cylinder there. So at this point, this is awesome because we don't have to do a bunch of grinding to notch the block here. We have one little spot there, but we do want to run through. Let's take these rods out and let's go down the rest of the cylinders here and check what they look like just real quick, just to make sure. And then let's actually put 2 pistons in on this side, just to double check there. But I think we're gonna have all kinds of clearance, but it's always good to check. So you can probably imagine how it might get slightly more complicated doing this with an actual piston. That's what I was worried about. Next row back, same way there, lots of clearance on that side as we come around, plenty of clearance there. Let's put the bore scope in and just look up the cam tunnel for fun. It's not even close. Lots of clearance. So just to give you guys a shot, The top of this bolt here, right there at the bottom side of that cylinder, that's as close as we get anywhere on these two cylinders. So I think we're in a good spot to just run through this really quick and we'll be on our way. Every time, man. Every freaking time. I'll look at that one a little closer, but let me get on that side. And okay, so from this angle, it plenty. So again, lots of clearance there. Let's check the other side. Again, lots of clearance. Haha, I did it without launching everything across the shop. I might have a little bit too strong a spring. As expected, on that side, again, it's hard to see when you're at the wrong angle, but clearance for days there. Same thing here. I can see all kinds of daylight as we go past that tightest point there. All kinds of clearance on that side. I know that you don't have the best angle there, but I can tell. If you look down in from the cylinder side, you'll see that the rod is nowhere close, and we're good there. If I flip over to this side, same story. All kinds of clearance. Let's pull this back out and we'll move over and we'll put pistons in on these front two cylinders and see how they look. I don't foresee any issues, but dang it. So I'm ready to drop a piston in here. Okay, pistons in. Yeah, we're gonna have all kinds of room, but let's go ahead and do the other side too. Every time. And again, we do have left and right pistons for these. So I'm just trying to make sure everything's oriented right. The pistons really do not even come out of the bottom of the cylinders, which is awesome. Plenty of clearance relative to the counterweights of the crankshaft. I had one a while back where the pistons hit the counterweights, but we've got, I'm going to say, at least half an inch here on both sides. So I'm going to say no concerns whatsoever with the pistons themselves. And I'm considering that they don't even come out the bottom of the cylinders at this point in time. I don't think there's even any point putting the other 6 in to check, because if they don't hit on the front ones here, they're not going to hit on the other 6 cylinders either. So All right, well, I'm happy, but need the cleaning guy's approval, so Dad, come here.
What do you got?
Well, I did all that work,
Yeah?
you know, to make the part to use to clearance this block.
Yeah.
And
I know you spent a lot of time doing that.
I think right there is the only spot I have to grind, this little bit. But maybe you take a gander, see what you think. We've got the pistons in there.
Okay.
See if you agree.
Where's your wrench to turn this with? Well, we was looking at that before. You've got all kinds of room between the rods and the bottom of the block. Counterweights look good. Looks like your pistons literally do not even quite come to the bottom of the cylinder, do they?
No.
The skirt is actually recessed up in the bottom just a little bit. That's like it was made for it. I mean, like factory made for it, not aftermarket, but factory made. And even over here where you're talking about doing your clearancing.
If everything's right, we shouldn't even need to there, but.
Yeah, I'm looking at that and I think I can see 60 thousandths between there. Yeah, maybe. Yeah, I'll bet there is. Between there already. So just to make you feel a little bit better, you take a little bit off of that where you got it marked, and I think you've got it whipped. And then are you going to go through and check all the others or call it good?
Well, we already had all the rods in all the others, but I'm not going to waste time putting the pistons in all the others, because if they don't come out the bottom of these cylinders.
Right. So that's why I was going to say, when you do your final assembly, just look at everything one more time just to make sure, but I don't picture you needing to do anything else in there.
I can't believe I'm saying this, but I think I like doing Chrysler strokers more than small block Chevy strokers.
Well, that's it. I was a little worried about you doing this thing, wondering what we'd get into, but this is going way better than that last 383 we did.
Yeah.
A lot less work on this.
We've got some high-dollar parts in this one, so.
Well, that always helps.
I mean, we had nice parts in the last one, but we have
really nice parts in this one, yeah.
So parts that were designed to be used together, custom parts, I think that helps it a lot. So at this point, I think I'm going to get the crank out of here, get things cleaned up a little, shave that edge off just a little bit to make me feel good where it counts, and get it cleaned up, and we can start working on getting it together maybe.
You know, sooner or later, things are going to catch up with you. You still got to get the camshaft in this. And you know how Chrysler cams fit Chrysler blocks.
Yeah, we might be in trouble there, but cross that road when we get there.
That's right. One thing at a time.
Oh, that's a heavy crank. Okay, so since we have so little to clearance here, and I honestly just don't want to clean up as much, I'm just going to use a file and file that off. Okay, I'd say that's probably good. So in this video, we made a custom tool for custom engine building with our brand new first CNC in the shop, and didn't need it at all because we hardly had to do any clearancing. I think I am going to do that for future jobs too, because it's nice being able to look down in without a piston in there. And like I said, I'm kind of clumsy. I'd probably drop a piston a couple times going in and out if I wasn't careful. So I think all in all, pretty good deal. And at this point, the machine work's done on this block. We can get it into clean, and we'll start getting cam bearings in and kind of start going through our assembly. So pretty cool. Stay tuned.